Hello everyone, welcome to another Watch Me Do Math video. In today's video we're going to be looking at the ENGAA paper from 2017, section 1, the first 14 questions in this video. The latter 14 questions in part A will also be looked at a later date. In addition to those, I'm going to look at the BMAT 2019 papers, section 2 Maths and Physics in a separate video before the admissions test date. So let's begin. First question, evaluate this square divided by this square. Okay, so when I see this kind of thing, I always say, think of it as a squared plus b squared plus 2a, or plus or minus 2ab, rather than putting this term in the middle, because it slows down how fast you work things out. So you go 12, root 12, 12, root 3, 3. 2ab, so 2 times 12 times 3 is 36, so 2 times 3 is 36, 2 times 6 is 12. 12 plus 3 plus 12 is 25. No, it's 27. And then here it's 12 plus 3 minus 12, cross cross, 27 over 3. 27 over 3, that's 9. So our answer is F. So again, you don't want to say things out loud if you can avoid it. Like in your head, the speech you go through when you are talking about a particular question, you only want to say the start and the end when it is as trivial a step as multiplying by itself or adding these three numbers up. So 12, 3, 12, 27 is an example of that. You don't want to say 12 plus 3 plus 12 is 27. You just want to say 12, 3, 12, 27. Because generally I find that you are not limited so much by your ability to do math in your head as by the way you speak about math in your head. So again, evaluate this. It goes to 9. Car is traveling a horizontal road in a straight line. The graph is velocity time graph, the part of the car's journey. During this part of the journey, what is the total distance that the car travels while it is decelerating? Okay, so it's only decelerating here because you've got a negative slope of velocity over time. So it must be the area of this trapezium, so it's 20 on this side, 30 on this side, which means there's an average side length of 25 multiplied by 20 seconds. 25 times 20 gets you an area under the graph of 500 meters. So the key thing to note here is that if you find any kind of trapezium on a graph that you are needing to work out, well, you can pull out your Suvan equations and go like S is equal to U plus V over 2t. The graphical way of looking at this is you find the midpoint here and then you go IS. So if that's the midpoint in time, then this is also the midpoint in height. And so this trapezium is approximately a rectangle of this height and this width, right? So now you know the width is quite easy to get, it's 20, and you know the height is quite easy to get, it's going to be like 27.5 because it's in between 30 and 25. And for instance, if I wanted to work this out, then I'd just go 27.5 times 2 is 55, and then times 10 is 550. And like so for this trapezium. So that was quite trivial, which is the distance traveled is the area under the velocity time graph. Next question, solve fully this inequality. Okay, let's move everything to one side, so plus x and then minus 15. So do all of that in one step, and then you want to factorize. So if ab is minus 30 and a plus b is 1, because this is plus 1x, okay, let's think about it. Something different by 1 but multiplied to 30, that's 5 and 6. So if it's a positive 1, then it must be plus 6 and minus 5. So you get 2x squared plus 6x minus 5x minus 15. And then you immediately see that this is 2x, x plus 3, and minus 5, x plus 3. And you don't even need to write the rest of it. Once you realize that it's 2x and 5 here, you can just go straight into writing 2x minus 5x plus 3 is greater than or equal to 0. Then, to solve a quadratic inequality, you want to take the two roots here. So x plus 3, you should immediately know that goes to a root of minus 3. And 2x minus 5, you should immediately know it goes to a root of positive 5 over 2. Think of it, if you see a linear equation, ax plus b is equal to 0 in your head, you should be immediately able to go, yeah, it's negative b over a. Or if you see x minus b, should be immediately able to go, it's b over a. Just like how you might see a quadratic equation, ax squared plus bx plus c, and think is equal to 0, and think is minus b plus this thing, the quadratic formula. you should be able to think of these as sort of the linear formula that you can easily use in your head to get a root of a quadratic equation as fast as possible. So you have -3 and 5 over 2, then it must be greater than or equal to 0, so given that it looks like this, because this is a positive a, it's from here and from here, because this is when it's above the x-axis. So less than or equal to -3, so this is single, we skip it out already, because a single inequality is not right. Less than or equal to -3, more than or equal to 2.5 here. Next, when a saucepan of water is heated from below, convection currents form and transfer heat to the liquid. Here are 3 statements about the water as it is heated. The mass of a fixed volume of the water increases. This is just straight up wrong. The density of a fixed mass of the water decreases. Fixed mass, yes, that is technically correct. And the volume of a fixed mass of the water increases. That is also technically correct. So which of these statements help explain how convection currents are formed? I would argue that both 2 and 3 explain how convection currents are formed, because 3 is a step in explaining 2, and 2 directly explains the effect because it means the fluid pressure is less when the density of the fixed mass of the water is less. Though I don't know. It is possible that the examiners would select 2 only. But the thing is, not including 3 would be overthinking it. And generally in multiple choice questions, you don't want to overthink it, you just want to answer something that is likely to be correct. So I would put G in a time-pressured situation like the ENGAA. Moving on to the next question. This equation gives y in terms of x. What is x in terms of y? Okay, you see this 5, it's on the outside, it's isolated, it's the first thing to eliminate. So y plus 5 is equal to this thing. And then you divide by 3. You can keep writing on the same equation without writing a whole new line for each step. So y plus 5 over 3, now you can just imagine this bracket. And then you square root, now you can just imagine what's inside this bracket. And then you add 1, now you can just imagine this fraction. And then you multiply the whole thing by 2, and you have x. What you want is that you are continually breaking the expression down into smaller and smaller pieces until you center in on the x, and at the same time you are just writing down the expression in terms of y step by step, such that you can easily see it appear. So while you may be tempted to do something like this and write out the entire equation again and again and again, I would say don't bother with that. Just keep in your mind a mental track of which element of the expression here you are removing until you get down to x, and then you see this 2 times 1 plus y plus 5 over 3. You see the plus or minus, you think, ah yeah, it must be plus or minus something. So helpfully the multiple choice questions have helped us remember that. And then it's 2 plus or minus root y plus 5 over 3, which is here, b. Now let's move on to the next question. An electric motor is used to pull a broken down car slowly from the road up a ramp onto the back of a breakdown truck. The car is a mass 1,200 kilograms, sensitive through a vertical height of 1 meter. The total input energy to the motor is 28 kilojoules and is 75% efficient. What is the total energy loss to the surroundings? Okay, so if input is 28 and 75% efficient, that means output is 21 kJ. That's because you should immediately recognize that 28, 3/4 of 28 is 21, and that 75% is 3/4. The car, 1,200 kilograms, is through a vertical height of 1 meter, and via GPE is mg delta h. This is something you ought to try and do in your head, because it's just 1,200 times 1 times 10, or 12,000, 12 kJ. You know that an amount of work of 12 kJ has been done. So the total energy that has not accomplished any work is 21 minus 12 is 9 kilojoules. And you can see they let us know that G is 10 over here. I shouldn't have assumed that G is 10, but I should like in general, it's safe to assume in these kinds of exams that G is 10, but they will tell you if you need to know it. So you have this answer B. Generally, the key to doing this question quickly is by skipping steps mentally. It's quite important to skip steps mentally and not write them down if you are trying to go fast, but at the same time, if you're not confident, write them down so you don't get them wrong. But I would say, generally, you are better than you think you are, than you think you might be at doing stuff mentally. So with you can improve very quickly with practice if you keep doing this kinds of simple maths and physics mentally. Because really you want to be getting through these first 28 questions as fast as possible to get to the latter half of the paper if you're doing the ENGAA, or you want to be doing these maths and physics questions as fast as possible if you're doing the BMAT. Alright, so question 7. Fruit stall sells apples costing X each and pears costing Y each. Sam bought 2 apples and 5 pears. Okay, so P is 2x plus 5y. Leslie bought 3 apples and 2 pears, which is Q. Q is 3x plus 2y. Which of the following is the cost of a pear? Okay, so you want y. Y is 2y is Q minus 3x. Y is Q minus 3x over 2. And P is okay. I think that was a bit of a false start for me. I should not have gone down that route, but what I think you should do in this situation instead is multiply the equations by certain factors such that you can subtract them and only y terms will remain. So for instance, multiply the first equation by 3 because of this 3 on the x on the other equation, multiply the second equation by 2 because of the 2 on the x here. And essentially you want to get both of these to their least common multiple, so you can subtract the second equation from the first equation and just get something times y left over, and then a thing in terms of p and q on this side. So multiplying by 3, we get 3p is equal to 6x plus 15y, and multiplying the second one by 2, we get 2q is equal to 6x plus 4y. Subtracting the 2, the x term is eliminated. You have 3p minus 2q is equal to 11y. And now you shouldn't need to do anything else because you can immediately see the term 3p minus 2q over 11 being the value of y, or option G. So ultimately the key to doing this simultaneous equation quickly was by identifying the least common multiple of these two numbers so that you can eliminate by subtracting one equation from another. That's generally a faster way to do simultaneous equations than variable substitution. Alright, next question. In one type of medical scanner, a source is placed inside a patient's body. This source causes pairs of gamma rays to be emitted simultaneously in opposite directions. Okay, detectors on each side of the patient use to detect the gamma rays. The distance between the two detectors is 3. When the source is at Q, halfway between the detectors, the two gamma rays arrive at the same time. In a particular scan, the gamma rays arrive with a time difference of this. Assume that inside the patient, the gamma rays travel at C. How far from Q, halfway between the detectors, is the gamma ray source? Okay, so if the gamma ray is traveling an additional amount, d here, that means this one is traveling less than a lesser amount by d. So the time it takes to travel to d is the time difference. And since d is vt for a constant v, where t is the time taken, you get you get okay, 2d is traveled in t. This is not an equation. D is vt, or 2d, the difference, is what would be traveled in this time the gap. So 2d is 4e10, 4 times 10 to the minus 10, whereas c is 3e8, 3 times 10 to the 8. So cancel 2 and 4 to get 2, and you get e to the 8 and e to the minus 10 cancel to get e to the e minus 2. So d is 2e minus 2, or 2 times 10 to the minus 2 meters, 2 centimeters. Ooh, that's not very nice. We've gotten this question wrong. Let me think for a moment. Okay. That's really quite strange. For this, traveling at c... Oh, no. I figured out why. It's because I forgot to multiply this 2 by this 3 here. So 2 times 3 becomes 6 e to the minus 2, or 6 times 10 to the minus 2 meters is 6 centimeters, which is an option here, D. Okay, so lesson learned from that. I did not write clearly, and that was the end of me. I should have at least noted in some clear manner that 2 times the distance was 3 times 10 to the 8 times 4 times 10 to the minus 10. You don't have to write times 10 to the, because you can just write e, like 3e8, 4e10. That's one faster way to perhaps a faster way to write times 10 to the something, because that's like the engineering notation behind it. So if you want to write stuff down, I would recommend you do that it that way at least. But anyway, I think it was the logic of this question that was a bit hard to grasp in the first place, like the thinking rather than the doing. P is kq squared. Okay, this statement means P is kq squared. When P is 2, Q is 4. 2 is 16k. K is 1 over 8. Q is inversely proportional to R. When Q is 2, R is 5. That means QR is equal to 10. What is P in terms of R? So if P is 1 over 8Q squared, and QR is 10, Q is 10 over R, P is 100 over 8R squared. No? Ah, it's cancelled. It's probably cancelled. 25 over 2R squared. And here we go. So, how did we think about this? Well, the inversely proportional statement, I will recommend, instead of thinking about it in the sense that Q is equal to K times 1 over R and working out K, I would say try and think about it in terms of QR is equal to K. And that K will be obvious when you realize you just need to multiply Q by R. And in the same vein, I think something I should have done here is write Q squared over P is equal to K instead of, or Q squared over P is equal to 8 immediately, because once I know that the constant of proportionality is going to be this Q squared, or P over Q squared is 8. Because once I know that, it becomes quite easy to determine P or Q, whatever, P or Q squared or whatever, right? So perhaps while that was kind of a flawed bit of knowledge, I don't think actually include that. Don't actually include that. I think this is generally safer because I'm more used to it. But at least for inverse proportionality, you should try and see how this form works for you. As in x, y is k. That kind of inverse proportionality statement. Alright, let's move on. When a plutonium-239 nucleus absorbs a neutron, it undergoes nuclear fission. One particular fission reaction results in the creation of xenon and zirconium. The nuclear reaction for this equation for this reaction is shown, but with some non-zero integers replaced by w, x, y, and z. Okay, let's think about this for a moment. W plus y is 240? No, that's wrong, because w plus y plus 1 is 240. Z is 240 minus w plus y. Yes, this is correct, because you can think of it like plus z0 in neutrons. So w plus y plus z, the total mass number, is going to be conserved. And so even though it's just z times neutron, z times neutron will get you a mass of z. So if 240 is w plus y plus z, then z becomes 240 minus w plus y. And immediately, since this option is correct, we can just move on from the question. In this kind of thing, where which equation is correct, it may be useful. There are a number of strategies you can take, and which one you take is your personal preference. So one could be checking each one this way. One could be looking at each one and trying to determine intuitively which one might be correct or which one might be wrong, so that you can eliminate before doing this again. But I personally prefer just doing this. Okay. Which of the following is a simplification of this? Oh god, this is disgusting. 9x squared minus 4. This is 3x minus 2, 3x plus 2 by the difference of squares rule. So 3x minus 2 is the negative of this. So this minus sign and this cancel out with this. And this x squared cancels out with this x cubed to get x on the bottom. And you just have 3x plus 2 remaining. So it's 2 plus 3x plus 2, or 3x plus 4 over x, or 5 plus 2 over x. So here the key was recognizing, because 9 and 4 are square numbers and you also have a square term here, especially since 9 is the square of this 3 and 4 is the square of this 2, that leads me to recognize that this top term here is a difference of 2 squares. And that's why I would factorize it into this form here before doing the rest of my magic. And one key thing to note is that a minus b is minus b minus a. That's one tool that I think is really useful. Adding a minus, multiplying a minus 1 into anything will cause a minus b kind of term to flip around. And that's always a useful thing to note. And also, if possible, avoid writing this out again, because you can do your simplification work on the printed expression rather than writing it out again before doing your own copy. Okay, an electric motor is connected to this. The motor is 12 volts. The motor is used to lift a mass of 20 kilograms by rope and pulley. Mass is lifted through 6 meters in 5 seconds. Complete system is 80% efficient. What's the current in the motor? Okay, so (6 meters, 20 kilograms, mg delta h gets you in your head 6 times 20 times 10, or 6 times 200, or 1200 joules. 80% efficient, that means you would recognize that this is 4/5 of 1500, because it looks like a multiple of 4, and 12 looks like 4/5 of 15. This is the sort of pattern recognition that helps you in these things. So 1500 joules is the input electrical power to the motor, and over 5 seconds, getting you 300 watts. 300 watts divided by 12 volts, you get 300 over 12. Well, this is 4, this is 100, and 100 over 4 is 25 amps. So generally, this kind of question it's very rapid fire. You are able to do the calculations quite fast in your head because they're nice numbers, but you have to recall all of these different electric energy relevant equations at once. So I don't know. My opinion on this is that the fastest way to do this is through your ability to pattern recognize in terms of like what simple ways can you get from one number to the next, and how can you avoid writing things down. Because it's good to get into the habit of not writing things down completely. There is no need, as there is in regular exams, to write things like P is VI, W is F over D, P is E over T, etc., etc. There is no real need to do that. Okay, what is the value of x that makes the following expression correct? 4 root 2. Okay, well, 4 root 2 is 2 to the power of, well, 4 is 2, and 2 is 0.5, so 2 to the power of 0.5, 2.5. And then 4 to the x is 2 to the 2x, 8 to the negative x is 2 to the minus 3x. You should be able to instantly do this through your knowledge of the indices rules, and 2 to the 3 plus 2x is itself. So taking log 2 of both sides, 3 plus 2x minus 3x is 2.5. 2 plus 2 minus 3 should immediately be recognized as 1. So if 3 plus x is 2.5, you should immediately recognize that x is negative a half, because you go down by a half to get from 3 to 2.5. By the power rules here, I mean to recognize that if you have something like 2 to the 2 to the x, this is equivalent to 2 to the 2 times x, right? It's that particular power rule. And finally, for our last question of this video, the nuclide PQX decays to the stable nuclide Y. During this process, 4 particles are emitted, an alpha particle and 3 beta particles. Let me think if there's any more. No, I cannot personally think of any more tips that might be useful in this particular question. In this question, it's about knowing your electrical physics quantities very, very confidently. Okay, this nuclide decays to Y. During this process, 4 particles are emitted, an alpha particle and 3 beta particles, which is not one that could be formed at any stage. Okay, so we cannot eliminate anything based on just this or just this. Let me think. Beta particles will increase the, let me think. Beta particle is a proton number at the bottom, -1, mass number is 0. Well, this is the atomic number. So you'd go Q, Q minus 1, Q minus 2, Q minus 3. Or Q, Q plus 1, Q plus 2, Q plus 3. Or with an atomic number lessened by 2, you get Q minus 2, Q minus 1, Q plus 1. I don't know. I'm kind of confused now because generally I would have thought that all of these are possibly formed. Oh, yeah, it's A, because if no alpha decay has been undergone, then the atomic number can only possibly go up because of the beta decays. But in this example, it's gone down, which is impossible because beta decays involve a neutron turning into a proton. You can only gain extra protons. And so this is why A is correct. P remains the same because no alpha decay has taken place. That's what you can tell about this question 14. But Q minus 1 is simply wrong because you would expect Q to be here if the pattern continued. At the same time, you would understand that this is incorrect because Q can never increase only on beta decays. Atomic number can never increase only on beta decays. Proton number can never increase only on beta decays. That's it. Alright, so until next time, I'm going to leave this video off now and do the other 14 questions in another part of the series. And if this video helped you, please be sure to subscribe and share it with your friends. And thank you for watching.